Okay, let me give you guys an example. So here's a situation. We've got two cars, car A and car B. This car here is traveling at a constant speed of 10 meters per second. This car is accelerating 3 meters per second squared. So in this video we're going to attempt to answer these questions. So here we've got when time equals 3, what is the distance of car B? What's the distance of this car? When time equals 4, what is the speed of car A? Or when time equals 2, what is the acceleration of car A, and so on. We're going to answer all these questions. But before we do that, we need to draw the graphs. So for car A, what does the acceleration time graph look like? Well, car A is traveling at a constant speed. So that means when time equals 0, the speed will be 10. It's always 10. The speed here will be 1 second later, time equals 1, the speed will be 10. The speed here, another second later, the speed will be 10. So speed will be 10. So the speed time graph will look like this. So the speed time graph will look like this. It's always 10, 10, 10, 10, 10. So when you come to draw this, just draw it like this. The speed will always be 10. So put a 10 in here. And what's the acceleration of car A? The acceleration time graph will look like this. There is no acceleration, so it's always 0 here. Because if you look at the top car, if you look at car A, it's not accelerating. It's traveling at 10 meters per second all the time. So so the distance time graph will look like this. Well, let's go back to here and see what it looks like. 1 second, the car A would have done 10 meters. Another second, it would have done 20 meters. Another second, so 3 seconds in, it would have done 30 meters, and so on. So the speed, the distance time graph will look like this. When time is 1, it would have done 10 meters. When time equals 2, it would have done 20 meters. When time equals 3, it would have done 30 meters, and so on. So the distance time graph will look like this. So this is a straight line, so you know it's going to be y equals mx plus c. C, the intercept, is going to be 0, so we can forget about the c. The gradient, well, if you look at this gradient, the height here, 10 meters in the first second, so the height is 10. The cross here is 1, so the gradient is 10 divided by 1. So that would be 10 divided by 1 would be 10. So the gradient would be 10. 10x, but then the y-axis represents distance, so y represents d, and x, the x-axis, represents time. So we would replace the x with the t. So our graph, the equation for our graph is d equals 10t. Okay, so this one here, s equals, speed is always 10, and here the equation would be acceleration will always be 0. Okay, so hang on. And for car B, the acceleration is always 3, because let's say the car, 1 second later, the car's trying to get faster and faster by 3 every second. The acceleration will always be 3 here, because let's say the car's here, the car is trying to get faster and faster by 3 every second. Even if the car's here, an acceleration means it's trying to get faster and faster by 3 every second. So the acceleration will always be 3. The speed, when it comes to the speed time graph for car B, it will look like this. If you have an acceleration of 3, it means that, well, here the speed will be 0 because it's starting from rest. 1 second later, the speed will be 3. Another second later, the speed will be 6, and another one will be 9, and so on. That's what acceleration means. It means your speed is increasing by 3 each time. That's what acceleration means. So your speed time graph will look like this. Your speed time graph will look like, well, 1 second the speed will be 3, another second later the speed will be 6, and another second later the speed will be 9, and so on. So your speed time graph will look like this, and the equation for that would be s speed equals 3t, because the gradient is 3 up, 1 across. Well, anyway, That's your equation for the speed time graph. Now, when it comes to distance time graph, you guys always forget what this graph will look like. But what you do know is that the area underneath the speed time graph represents the distance traveled. So you imagine this distance here at any given time. Let's call it t. The height here would be 3t. So the height here would be 3t. So if you put the t into here, it would jump to the line. So the height would be 3t. The across here would be t. Well, the area underneath here represents the distance traveled. So you would get 3t, which is the height, times the width, which is t, and then that would then give you a rectangle, and then you would cut it in half, divided by 2. So this thing here represents the distance traveled. So 3t times t, that would be 3t squared, and then over 2. So this thing here is your distance traveled. When you get to this stage, imagine this as this 3 over 2, and then you've got a block of t squared here. So this is really a quadratic. So it looks like this. So y equals x squared will look like this. But because you've got this coefficient, it makes it steeper. So imagine this in your mind. So you've got your quadratic there, but you can't have negative time. So we would erase this. So our equation would be d equals 3 over 2 t squared. Okay, so let's start again here. So given this scenario here, the acceleration time graph will look like this for car A. There is no acceleration. For speed time graph for car A, speed time graph is always going to be 10. So when you come to draw it, just do that, 10. And the distance time graph will look like this, and it's going to be 10t. And for car A, the acceleration time graph, for car B, the acceleration time graph for car B is, well, it's always trying to get faster and faster by 3. And the speed time graph, well, the speed increases. If there's an acceleration of 3, the speed increases. So it's going to look like this. So speed equals 3t. So the gradient of this represents the acceleration. And the distance time graph will look like this. Just draw the quadratic in your mind, and then get rid of negative time. And the distance is really the area underneath here, and it turns out to be 3 over 2 t squared. And then to answer these questions, what is the time? What is the distance of car B at time equals 3? So which of the 6 graphs will you look at? Should you look at this one? Which of the 6 graphs should you look at? Well, you're interested in car B. So this whole thing here represents car B, and you're interested in distance. So you should be looking at the distance time graph of car B. You shouldn't be looking at of car A, the distance of car A. You should be looking at this graph here. So to answer this question, you should look at this graph here. When time equals 3, when time is 3, what is the distance of car B? Just put this into the formula and then work it out. So put 3 into the t, square it, that would be 9, times 3, that would be 27, 27 over 2. So the distance will be 27 over 2. Now the next one will be, distance will be meters. So it's 27 over 2 meters. And then what is the speed of car A at time equals 4? So in your mind, which of the 6 graphs should you be looking at? Well, if you're interested in the speed of car A, well, car A, you should be looking at one of these 3. Well, you're interested in speed, so don't look at acceleration, don't look at distance, look at the speed time graph. So look at this graph here to answer this question here. So when time equals 4, what is the speed of car A? Well, put 4 into there, it would jump to here. It would be 10. So the speed here will be 10 meters per second. Because if you think about it, what is the speed? What is the speed of car A? Well, car A is always traveling at 10 meters per second. It's not It's not accelerating, so it's always going to be 10. It's traveling at a constant speed, so the speed will always be 10. Right, next question. When time is 2, what is the acceleration of car A? Well, car A, you should be thinking about these three graphs. You're interested in acceleration, so you should be looking at this graph here. What is the acceleration of car A when time equals 2? So put 2's here, the acceleration 0. There is no acceleration. So if you look at car A is not accelerating at all. It's not traveling faster and faster. It's traveling at a constant speed. So there is no acceleration for car A. There is no acceleration. So the answer would be 0 meters per second. The unit of acceleration is meters per second squared. And then this question here, what is the acceleration of car B at time equals 1? Well, you should be looking at this graph here, because car B is this thing, acceleration is this graph, and time equals 1, so put 1 into there, it would jump to here. The acceleration would be 3. It's always 3. If you look at this, if you look at car B, the acceleration is 3 all the way through. So if the car's here, it's trying to get faster and faster by 3 every second. This, if the car's here, it's still trying to get faster and faster by 3 every second. Well, the acceleration would be 3 meters per second squared. And then, what is the distance of car A at time equals 4? So you should be looking at, well, car A, you should be thinking about these three graphs, and you're interested in distance, so you should be looking at this graph. So what is the distance? What is the distance of car A at time equals 4? So put 4 into here, jump to the line, so that would be 40. So 40, what's the unit of distance? It would be meters, so 40 meters. And the last question, what is the speed of car B? Well, speed of car B, you should be jumping to this graph here. Speed of car B. So look, jump to the jump to the speed time graph of car B. So you should be jumping to this graph here, and you want to know the speed at time equals 5. So put 5 into here, and then it would jump to here, which will be 15. So the answer here would be 15 meters per second, because it's speed. Okay.